Hi students, this is Sivaji Karuppusami. I'm a communications engineer who loves mathematics and science, and I'm teaching class 10 mathematics to my niece, and I thought to begin a video series so it can be useful for you all who are watching this now. I believe the most efficient and interesting way to learn maths and science is to understand how it is used in real life. Today, let us learn about HCF, highest common factor. Like I mentioned, I'm planning to teach each topic with a practical application as much as possible before we actually look into the topic so we can enjoy learning it. Let us assume a fruit seller is trying to place apples and oranges in the showcase. He has 36 apples and 84 oranges, but he wants to showcase them in such a way that the apples and oranges look equal in numbers when looked from the shopper's view, and occupy the space as efficiently as possible on the showcase tray. In order to achieve this, he can either try to put 5 apples and 5 oranges each in the first row and see how it looks like, and then try 7 of each and so on until he finds his answer, which is obviously a trial and error method and it takes a long time to find the answer. But we can help him to find that number very quickly and efficiently by finding the HCF of these two numbers 36 and 84. This is just one of many applications of HCF in real life. We will be looking into prime factorization method and Euclid's division algorithm to find HCF in this session. Before we dive deep into the methods, let us quickly remind ourselves what the prime and composite numbers are. Prime number is a number that can only be divisible by itself and 1, whereas a composite number is divisible by more than 2 factors. Now, let's look into the prime factorization method. Okay, it involves 3 steps. First, we need to find the prime factors of given numbers a and b individually. So we need to find the factors of a separately and b separately, and then find the common factors amongst them, and then multiply those common factors, and that will be the HCF of given numbers a and b. Now what we do, let us go back to helping our fruit seller. So his problem is he's got 36 apples and 84 oranges. Okay, so with the prime factorization method, let us try and find the HCF. 36. Let us take 36 now. The least possible prime factor is 2. Dividing 36 by 2 gives 18. Now again, the least possible prime factor is 2. Dividing 18 by 2 gives 9. Now the least possible prime factor is 3. Dividing 9 by 3 gives 3, and so on. So we can just list the prime factors that we have found for 36. So the prime factors are 2 and 2 and 3 and 3. Okay, now what we do, let us move on and try and find the same thing, the prime factors for 84. So let us take 84. The least possible prime factor for 84 will be 2, and then dividing 84 by 2 gives 42. Now the least possible prime factor is again 2. Dividing 42 by 2 gives 21. Now the least possible prime factor is 3. Dividing 21 by 3 gives 7, and so on. So now we have the list of prime factors for 84. So let us go on and list them now. So prime factors of 84 are 2, 2, 3 and 7. So now we have completed the first step, which is finding the prime factors for the given numbers a and b separately. Okay, the second step is to find the common factors amongst them. So you can see, let me underline the common factors. So you can see 2, 2 and 3. These are common amongst the prime factors of both 36 and 84. So we now identified the common factors. Now the method to find the HCF is actually multiplying these common factors. So HCF of 36 and 84 will be 2 multiplied by 2 multiplied by 3, which will be 12. Having found the HCF using prime factorization method, let us look into the second method, which is Euclid's division algorithm. First, we need to understand what is lemma, what is algorithm. Euclid's lemma is just a statement, and algorithm is nothing but continuous process of using the lemma until the remainder becomes 0, at which point we will get the answer we are looking for, HCF. Okay, if we take two integers a and b, there exists integers q and r to satisfy the equation a equals bq plus r. We can try and understand it with two integers. Let us take 3 and 13. They have also mentioned that a must be greater than b. So we will take a equals 13, b equals 3. Now we can write the lemma 13 equals 3 times 4 plus 1. So let me mark each of them so we know what is a, b, q and r. So this is the lemma. So we can write any two integers in this format. That is what we need to understand. Here I have not talked about 0 less than or equals r less than b. Let me just explain what that is. It is so simple. If you remember from the basic division concept, whatever is the divisor, the remainder cannot be greater than the divisor. So here b is divisor 3, and 3, if you divide any number by 3, the remainder can only be 0, 1 or 2. That is what they have written there. Okay, now we understood how to write the Euclid's lemma. So for any given integers a, b, we can write it in the equation a equals bq plus r. So that is valid and we can write it in that format. So using this, we are going to find HCF. How? We will keep writing these equations until we get to the point r becomes 0. Let us see how to do it with the example. Our fruit seller is still standing there wondering how to put apples and oranges around. So let us just consider his problem. So he has got 36 apples and 84 oranges. Now the lemma format is a equal to bq plus r. Okay, we need to consider this condition that a has to be greater than b always. So we need to bear in mind all the time, otherwise lemma is not going to be valid. Okay, so now we decided a has to be 84 and b should be 36. Now step 1 will be 84 equals 36 times 2 plus 12. Yeah, here R is 12. So we know that R is not equal to 0. That means we need to carry on using this lemma. So we need to go to step 2. When we go to step 2, what we do, we actually take the value B of the step 1 as A and the remainder R as B in step 2. Let us see how we do it. I'll just mark it so you can easily understand it. So 36 equals 12 times 3 plus 0. You can see that. Let me just draw the line so you can see how I derived the step 2 from after step 1. So the 36 comes here. So B becomes A, R becomes B for step 2. There it is. So now in step 2 we have got R equals 0. That means we can stop the process, and whatever is the value of B in that particular step when R becomes 0, that is the answer we are looking for, the HCF. So the HCF of 84 and 36 is 12. There is an interesting characteristics here which we can note. This 12 is the HCF of 84 and 36 and also HCF of 36 and 12. That is, HCF of step 1 equals HCF of step 2 equals 12. In another problem, if we have to do 3 steps until R becomes 0, then the HCF found on step 3 will be the HCF of step 1 and step 2 as well. So this is the interesting phenomena to note. I have used the variables A and B in algorithm for ease of understanding. In textbook, they've used A and B when explaining lemma, C and D when explaining algorithm. As it might cause confusion, I just used A and B on both lemma and algorithm. As you understood the concept, it doesn't matter what variable is used. I hope this has been useful and informative to you. If you have any questions, please add it in the comment section and I will try to answer it as soon as possible. I will be solving the exercise problems in the textbook in a separate video, so subscribe to the channel to get the notification when that video is posted. If you like the video, like and share, and I will see you in the next video, and I wish you all the best.